Let's now enhance our previous program a little bit. Here's what we wrote. We created by hand a linked list of points. Each point was a structure consisting of an x-coordinate, a y-coordinate, and an address that we called next that stores the address of the next element of the linked list. Then we created 3 points, PT1, PT2, and PT3. We initialized them with some components and so far didn't link them together right then and there. We also declared 2 pointers, start and PTR. Start was supposed to point to the beginning of the list, and PTR is going to help us move through the list later on. We initialized start with the beginning of the list, the address of PT1, and then linked PT1 and PT2 together by storing the address of PT2 in the next component of PT1, and then linked PT2 and PT3 together by storing the address of PT3 in the next component of PT2. And this allowed us to then move through the list with a while loop, knowing only where the list starts, and using the next component to move through the entire list, printing out the x and y components of all the points on the way. Now, seeing such code in the main function makes you think we should really move that to a separate function. And that's what we're going to do. We're going to write a function print points, and we're going to simply pass the beginning of the list to this function print points, and the function is going to take care of the printing. So here we just want to call a function print points, which we still have to write, and we pass the start of the list to it. In other words, we don't even need this pointer PTR here in the main function anymore, because that's only going to be useful in our print points function. So this is going to be moved away out of here. And maybe we want to have that function right here, so it doesn't return anything, print points. And we pass into it a pointer to a struct point. And let's call that PTR. Let's start. Let's have another show memory command right here. We can keep track of more memory. So start equals, in this case, it's still the same as before. But I want to also show a cursor PTR. I'll show you what that looks like when we do that. Okay, so we need our pointer here, struct point star PTR, because we need something to move through the list. And I'm going to simply paste in the code we had up top. So PTR is initialized at start, and while PTR is not the null pointer, we move through the list. You notice that we don't even need to know how many elements are stored in the list. We only pass where the list starts, and then we move through the list with a while loop instead of a for loop, because we don't know how long it is. And we move through the list until we hit its end, being indicated by the fact that PTR is pointed to the null pointer. And that's all we have to do. All we now need is a prototype. Let's put that up here. Put a semicolon behind that. And we are ready to go. We moved print points into its own function. Let's give it a try. Here we go. We declare the 3 points again as before. They show up in memory. And next we link them together. We give start the address of PT1, which is here FFF4. We move to the left there as a FFF4. We link PT1 and PT2 together by storing the address of PT2 in the PT1.next component. There it is, FFE8. And then we link PT2 and PT3 together. And now we call the function print points, and we pass to it start. Start again has the value FFF4, which is the address of where PT1 is stored. So that's what we know in my function print points now. So start in print points has the value FFF4. You can see that right there. Start is the one that's furthest to the left, FFF4. And then there's a PTR that's declared inside the function, and it gets the value also that start currently holds to FFF4. PTR is not the null pointer, so we enter the while loop, and we print out the components x and y of the point to which PTR is pointing. In the memory visualization, you see that PTR is pointing to PT1, and so it's going to print the x and the y component of that, 1 and 2. PTR is updated, now points to PT2, and we print the x and y components of that, minus 2 and 3. And next, PTR points to PT3. And there we print the x and y components. And now PTR is updated to null, which makes us exit the while loop, and the program terminates. In this particular example, when I declared the points right one after the other, they appeared right next to each other in memory as if they were sitting in an array of points. However, had I, for example, declared another variable earlier, so for example, this one, I'm just going to declare this variable in a different location, so to show you that this is actually not necessary. So how about I declare PT1, and then I declare my pointer start, and then I declare PT2 and PT3. If I now run this program, you'll see they're no longer adjacent in memory to each other. So here's PT1, then there's my start, and there's PT2, and this won't disturb anything. These points could be sitting anywhere in memory. They don't have to sit next to each other because I just keep track of their address throughout the program. So the program just works just as fine. PT1 start holds the address of PT1, FFF4. PT1.next is FFE4 now, which is the address of PT2 in its new location. And then PT2.next is the address of PT3. Then we print, and everything just works just as well as it did before. So the points don't have to sit next to each other, and this is what's going to happen in reality. In reality, we're going to allocate space at runtime for these structure elements using the malloc function, and so we have no control over where that's going to be in memory, and it doesn't matter because we keep track of these addresses by hand.